Oh, there it goes. Okay, so this should all be properly in Canvas. You guys actually were pretty much already put together for about 2 weeks for this unit. It's just things sort of got shoved backwards because I wasn't here for a few days. I am not going to be able to write on the board because we all know my smartboard drives me nuts when I even attempt to. So I'm going to have to do this on the dry erase. So I will vocally explain what I'm doing on the board. You need to be able to tell the acids apart. Okay? And a lot of the different acids have multiple types. Okay? We know that they're acids. They all start with hydrogen. They say acid in the name. Okay, so which element besides hydrogen, because I know they all start with hydrogen, so I'm going to start off with doing H. What's the charge of hydrogen? Positive 1. Okay, so I'm going to do all three of them side by side. So I know that they're all starting with H plus 1. Okay, and so some of them are going to have oxygen in them, okay, and some of them are not. And that's sort of the hard part about acids is there's different types. So what's the other element that these 3 acids have in common? Okay. Sulfur. Okay, so I'm going to do the hydrosulfuric first. So I know they're all going to have, now which one does not have oxygen in it? The hydro one. Okay, so I know, so I'm going to do that one first. So sulfur is -2. It's a 2. So let's build the easy one first. What's the formula for hydrosulfuric acid? H2S. H2S, right, because you flip-flop. We don't write ones as a subscript. I write ones as coefficients, and I write ones as charges. Some teachers, if you take chemistry in college, sometimes they don't. But I was trained to do it. And now, here comes the hard part. We got to figure out the difference between sulfurous and sulfuric. So which is which? Because I know I'm going to have sulfate and I'm going to have sulfite. Sulfuric is H2SO4. Right, sulfuric, the silly little way that I taught this and that I've kept this straight because I ate it, it's icky. Okay, so now I'm not going to force you to memorize the polyatomic ion chart. I need to go through the test and make sure that you guys have what you need. If you don't, I'll give you one of these, and then I'll give you the polyatomic ion chart itself because I'm not making you memorize it at this point. So I know the sulfurous comes from sulfite, so I would either have to memorize it or look it up. Sulfite is SO3. It also carries a -2 charge. Sulfate is SO4, which carries a -2 charge. 8 does not mean 4 oxygens. No. And when I first tried to explain this, I was using azole stuff. And there was like, if it's 1 oxygen, it's this, 2, 3, 4, and then there were all these exceptions. But if you do it, the 8 becomes ick and the ite becomes us. You don't need any exceptions. 8 does not mean 4. 8 means more, and ite means less. That's all it means. So how would you build the sulfurous acid then? H2SO3. And then the sulfuric acid would be H2SO4. Because I don't like having to make you guys memorize a bunch of exceptions. And unfortunately, chemistry's full of it. They're everywhere. But this ite becomes us, and then you crisscross if they don't add to 0, and the 8 becomes ick, and you crisscross. It just depends. Am I asking you to write the formula, or am I giving you the formula and I ask you to give me the name? Now, I'm still trying to get caught up with grading. The chemistry takes me forever to grade, especially when I have to go back and pay attention to what, like, writing down. I can tell you, I put in, because I tried to digitally go into attendance and fix you guys when I had subs, and it got overridden again. So I gave up. I'm printing out one of my spreadsheets, and so I sent that this morning. If you're having an attendance issue, it's going to take them a little while because they have to go back and they have to override everything. So I put it in. We'll see how long it takes them to fix it. I swear I'm working on it. I don't think it's in this class, but I have a few parents that are sort of breathing down my neck, and I'm like, I'm trying to fix it. I cannot make the attendance office work any faster than they can. Neutralization reactions is the last bit that's on this test. It's been a while, and I can't even remember what, I don't know if I glued this out. It's been a while since we've done this, but you have to be able to predict products at this point. Okay, and we'll go through a couple of them. You have an acid-base reaction. So of your reactants, one of them is an acid and one of them is a base. And you need to be able to tell me when you do put them together in the reaction and they react, what are the things they're going to turn into? One of the things it's going to turn into is, what's the matter?
What was the last one?
Oh,
H2SO4.
H2SO4. It was H2S, H2SO3, and H2SO4. I'm sorry, I thought everybody was done with that. When these two things react with each other, they don't just like explode and make smoke or anything. They make two things. They make a salt, not like a salt, but a salt, like what you eat, the little rocks that we eat. And then the other thing that it makes is water. Every single time. You just need, and you should know by now that water is H2O. But what is this thing's formula going to be? And just like how I crisscrossed for the acids, because a salt is an ionic compound, you're going to crisscross if they don't add a zero. We're going to do the first thing, we're going to label the reactants if they're an acid or a base, which you guys should have most of this on here because it's going to take a little bit for you to be able to do this. You are going to figure out what makes it an acid, which is the hydrogen, and what makes it a base, which is almost always hydroxide. We're going to make sure that things are balanced. Okay, so you don't have like extra things showing up. If they're not equal, you have to balance the equation. It's just been a while since we've done it. Your circle things, the hydrogen and the hydroxide, those make water, H2O, HOH, which is the way we do it in biochemistry. We literally write it HOH, but it's H2O. And then the things that are left over, the metal from the base and the non-metal from the acid, that's the salt. You just need to know what your charges are, whether they're polyatomic ions or they're elements. I mean, I keep printing off the same periodic table over and over and over and over that has the charges on it. You guys should have one if you've kept up with it. And you need to make sure that your metal is first and your non-metal second in salt. Otherwise, it's not right because metals always come first. So, and if you hear cation, that is the metal. That's the positive ion. It's just been a long time since we've done nomenclature, which we talked about this yesterday at lunch. That's so not animated right. Oh, well, I'm not going back and fixing it right now. That we need to take this and move it with the ionic and the covalent stuff because that's really where it fits. And then come back and do pH and stuff later. So I have hydrochloric acid that's reacting with sodium hydroxide. Okay, they're going to make two different things. You can already see my coefficients. This thing's already balanced. So we have, this is what makes the hydrochloric acid the acid. And I know you're still trying to figure out how to name some of these. This is what makes the sodium hydroxide a base. They're going to come together to make water. And the bits that are left over, yes, you need to know your charges, are going to make the salt. So the HCl is the acid, the NaOH is the base. I'm going to form two things, the H2O and the sodium chloride, which is what we call salt. It's called salt because it is a salt. They're little rocks that we like to eat. These two are going to come together. You need to make sure that the metal is first and the non-metal is second. Now, I know that that's the way the formula is for sodium chloride. Sodium is +1, chlorine is -1. They add up to 0. You don't have to write any subscripts. If you want to write water as HOH, you are more than welcome to do that. But I knew that this was the formula for the salt because the sodium was +1 and the chlorine was -1. And if you forget your charges, they should be on your periodic table, or they should be on your polyatomic ion chart, which I need to pull that back up towards the top of the module in Canvas, wherever I put it. Just need to go find it. So it can get way more complicated than this, but this is essentially the gist of what is called a neutralization reaction. The acid and the base are neutralizing each other. Water is neutral, it has a pH of 7. Bases have a pH above 7, and acids have a pH below 7. Hydrochloric acid's pretty strong. That's the stuff that's in your stomach. It has a pH of like 2. It's actually less than that, but I'm not going to go into decimals with it. The second one, I have potassium hydroxide, and I have, this would be perchloric acid, right? Yes, perchloric acid. Had to think which ion that was. The hydrogen is what makes this acid the acid. The things that are going to combine are going to be the metal first, the potassium, and then the perchlorate ion, the ClO4. And if you don't know the charges of them, you would have to look them up. So I know in this case, they're just flipped. The base was first, the acid is second. I'm still going to make the salt. The potassium, the K is +1, the ClO4 is -1. You add the 0, and it's going to make water. And this one was also already balanced. So I knew it was KClO4 because it was +1, -1. That is your salt. It is potassium perchlorate and water. That's the hardest part. And make sure you put the metal first. Mark it wrong. Like I said, I need to go back over and double check your test because I've already printed the review. Because like I said, we all do the same thing. But we will be going over this tomorrow. And I think I will be here 100% sure. I think I'm going to be here tomorrow. I expect to be here tomorrow. It's something weird.
I just realized today's Thursday.
Today's Thursday. Yeah, my weeks are all kinds of messed up from missing. I'm not used to not being here. It drives me nuts when I'm not here because I just get off track. Oh. I'll take attendance for you guys. And like I said, I am working on trying to get your attendance fixed. I am working on getting stuff graded. I just keep running out of time.
You know the school did help my team falls online.
Tomorrow?
Because the school, so one day so my mom had ended up coming home early, and I was still doing my schoolwork. You know the school had called my mom saying I wasn't doing my schoolwork that day?
Okay.
And she was sitting there watching me do my schoolwork.
I don't know. I mean,
And then more than once, I was like, bro, how?
now I know at the beginning of the year, it was absolute chaos when we were having to do things on paper and we had yeah, those first few weeks of school, that was nuts, but it shouldn't have been.
No, it was like toward like, I just kept moving. Saying I wasn't doing my schoolwork.
I don't know. Here. Yeah, it took us a little bit to try to figure out what was going on. And then they changed the way that we could code you guys. It wasn't just absent and present, and they brought in the remote synchronous, which we don't use, and the remote asynchronous. That was fun.
Which are both secret.
I don't know. I don't even know why it's an option. Because we're not. I don't know why it's in the attendance. Like it's one of the things we can click. I don't know. Things don't always make sense, unfortunately. For this one, I've got calcium hydroxide. The OH is the base part.
One was like something that like, I think they made it and they said it was like for the time to come in.
Yeah, it had to do with what your grades were like. If you failed more than 6 weeks or something like that, then you come back. And of course, then we have people still going on quarantine. Now, this whole year has just been
I knew I was gonna fail.
like it's just crazy.
I knew I was gonna fail last semester, even though I kept telling my dad that I may not pass this year. If I didn't go back, he wasn't gonna come back.
Like I said, it's been crazy for you guys. It's been crazy for
And then he wanted
us.
to get upset about my grades. I was like, I literally told you I needed to come back, or else I wasn't gonna pass.
Are you passing on?
I don't know. I don't know if I put my charges up here. I did not. Okay, so with the right-hand side, the calcium is +2, the iodine was -1, so that's why there's 2 iodines for every 1 calcium. I don't have to worry about that with water because I know it's H2O. Now, I've already balanced them for you, okay? But I had 1 calcium on both sides, so that was okay. I had 1 iodine on the left, but I had 2 on the right, so I had to put the 2 in front of the acid. It's been a while since we've done this. And then with the water, you had 2 oxygens and you had 2 + 2, which was 4 hydrogens, so I had to put the 2 in front of the water. But I went ahead and just balanced them for you. I should have probably gone back and animated those coefficients in.
What's the one here? Is the bottom or the one there?
I'm doing the,
Nope.
yeah. Uh-huh.
I saw the bottom one.
Oh, I haven't done that one yet.
Oh.
I'm sorry. I was like, what? Okay, this one,
That's all.
we've got the sulfuric acid reacting with the lithium hydroxide. You're gonna have your hydrogen reacting with your hydroxide. So the first one is the acid and the second one is the base. And then you're going to have the lithium first, which is +1. And it's going to react with the sulfate, which is -2. So you're gonna have to crisscross those. So you need 2 lithiums for the sulfate ion. I just didn't put my, I don't think I put my charges up there. But the lithium sulfate now will be your salt. And then obviously the H2O is water. And I already balanced it for you. I have to go, like I said, I need to go back and double check the test. I didn't look through it very thoroughly as far as, are you gonna have to balance? But if it's on there, then I'll make sure that it's in the review tomorrow. I just, like I said, just, it's been weird. Timing has been very, very, very weird the last couple of weeks.
It's been very good.
Ugh. And then the hail last night, that was awesome.
Did I walk inside from getting all the groceries out, and I was soaked from head to toe.
Yeah, I could hear a couple of them on my roof. I mean, like, it wasn't, man, my poor sister got baseball size hail.
I mean, my mom was driving home and stuff, too.
I'm
It
glad
was-
you didn't get baseball size hail.
I told my mom,
It was
like
destroyed the cars that were in her driveway.
I know, I'm glad because my car was got destroyed.
It, I don't know. I mean, I know this area gets some pretty nasty, it does, it gets some pretty nasty stuff. I know this wasn't animated right.
Almost broke a couple.
That's not good. And the last one that we're gonna do, we got the barium hydroxide. So the OH is the base part, reacting with the phosphoric acid. The H is the acid part. That's gonna make your H2O. Your salt is gonna be the barium, which is +2, and the phosphate, which is -3. So I'm gonna crisscross those. Base, acid, and then obviously water to H2O. And then as far as the balancing is concerned, because I don't do all this, oh, here, there's the salt and water. I don't do all the math underneath it. I literally use my fingers, like literally on the paper. So you had 1 and you had 3. So this is why I got my 3. Okay, and then I had a total of 2 × 3, which is 6 hydrogens. Well, actually, let's see, I balanced this one next. You had the 2 phosphates, I put a 2 here to fix the phosphate. So here I've got 6 hydrogens, plus another 2 × 3 is 6, which is 12. So that's why I put the 6 in front of the water. And then my remaining number would just be that 1 for the barium phosphate. Now, if you go off and do all the cool, fun stuff in college, which is going to be the only time that you're ever going to deal with chemistry outside of this class ever again, you're probably going to do a titration lab. Titration lab. And they have this gigantic thing called a burette. It looks like a really long, skinny, graduated cylinder. Yes. Sure. Okay. I don't know where my class went. It vanished. And you're going to have a known concentration of acid and you're going to have an unknown concentration of the base. And you're going to put something called phenolphthalein in with the stuff that you're titrating into. Okay, so you've got the acid in, the known acid in the Erlenmeyer, and you're going to put the unknown concentration of the base into the burette. And you're going to, all the weird words that people are just going to be giggling. All right, so there's this valve on the side of this glass tube that's called a stopcock. That's what it's called. And when you turn it just right, it opens a hole and it allows the base to come through. And you're going to let it slowly go from the burette into the beaker until you see a color change. And with phenolphthalein, when it's in the presence of a base, it turns bright pink. Like, you don't want it to get to that point, like Pepto-Bismol kind of pink. It's saying in the notes magenta, but no, it's not magenta. It's this hot pink color. You're trying to see the point where you just go over it being neutral and into a base, which is called an equivalence point. So I have not done that with a high school student since I taught pre-AP chemistry like 15 years ago. That was the last time I did a titration lab. It's a matter of getting the right base. Let's see now. With this, there's one more slide. Couldn't remember if there's one more. All right, last one. You can use a digital pH meter. Okay, that's the cheating way. Or, like I said, you use the phenolphthalein, and you're looking for that tipping point where it starts to change color. Not the Pepto-Bismol level hot pink, like very, very, very light pink. It's just starting to change. And this is how you spell phenolphthalein. It's the phenolphthalein, like the pH is completely and totally silent in the back half. And it's not really magenta. We keep saying magenta in the notes, and I don't agree with that because it is hot, hot, hot pink. Now, that is the last of what should be on your test for, I say tomorrow, I mean Monday, because originally your test was going to be tomorrow, and you would have been today. I know there's some matching on it. We will review for it. If you did not do the assignment with the pH, this one from yesterday, I'll have to write on the board. When you're trying to figure out, like if you know the pH and you don't know the pOH, you subtract the pH from 14. Or if you know the pOH and you don't know the pH, you subtract the pOH from 14. You're going to do the same thing for your 10 to the power, but they should add up to negative 14. You're still trying to find the difference to 14. And like I said, they're very, very, very nice to y'all on this because they are using whole numbers for exponents. They're not using decimals. That's what makes the math a little bit more difficult. Is when you have to do the advanced logarithm stuff. Okay, so that is it for today. Let me stop this. Let me double check online again. It's frozen. That was very loud. You're still, stop it.